Meeting is being recorded.
All right, good evening, everybody, and welcome to the April edition of our astroimaging special interest group. As we usually do, I'll ask if we have any new folks on the Zoom call tonight. And if we do, if you'd like to go ahead and introduce yourself, please feel free to do that. No new folks. All right. We always have time at the beginning for beginners' questions, but I think tonight we're going to deviate from that a little bit. And I think Jeff is going to give us a brief report on our activities from last week at the Chiricahua Astronomy Complex.
It'll be both, actually, because Jim Long is going to partner with me on this.
Okay.
So last weekend, Sunday, Monday, we had 10 or 12 of us down at CAC. We had almost relentless clouds, high wind, and regular dustings to bursts of rain. Somewhere around 4 o'clock in the morning on Tuesday, just before the Tuesday morning folks were going home, Craig Harding managed to find a small hole in the clouds so that he could conduct a test on a CAC telescope that he had been repairing, and the test was successful. But that was about the only clear sky we got in 48 hours. But lots of learning and camaraderie. Our group ranged from beginners to veterans. We spent a decent amount of time in a group just talking through issues that each one of us is facing, and people chimed in with their ideas on how to solve them. My sense was that even the most experienced of us learned something. We also had some opportunities to do some deep dive troubleshooting for a couple of folks, and Jim is going to talk about that in a moment. Our event also included an in-depth tour of the CAC site, including the 32-inch. We didn't get to see it move, but we got to see the roof roll off and got to peer down through the front of the telescope and learn more about it. And then plenty of time to socialize over meals. So I'm just going to share my screen quickly. I've got a few pictures that Jim captured. And I want to go to this share entire screen and go here. Everybody seeing that?
No.
No.
Not working, huh?
Okay. iPad. No.
Well, one more try.
Sure.
Here we go. Entire screen, allow. Now, how about it?
Looks good.
Yep.
Okay, so this was, I'm not sure exactly when Jim took this, but this is about as good as the clouds ever got. This looks like dinner one evening. We had
those were Monday.
That was Monday. Okay, this
No,
was a barbecue.
all of those pictures. All those pictures are from Sunday.
Oh, these are Sunday. Okay.
Right.
There's Jim Knoll and Craig at the 32-inch. And there's Jim Long peering down the 32-inch. And that was a dinner that a few of us stragglers had down in beautiful downtown Elfrida. If you're out that way, the country cart spelled with a K with two
Country
Ks.
Cafe. Yeah, it was a
Country Cafe is I think we all agreed is to be highly recommended. So with that, just to give you a little more detailed sense of some of the stuff we did, I'm going to turn it over to Jim, who was facing an autofocus problem with his rig.
I share my screen too. Let's see if I can do that. Okay, I have a few slides that kind of describes what we were talking about. Can you see that, or is it a black screen? There it is.
I could see it for a second and then there we go.
You can see it?
Now,
So,
yes.
so up until this point at this meeting, when I had experts to ask these questions, I was not able to attain focus with any of the telescopes that I own using autofocus. That's still slightly true. It's getting better from some of the advice I got, but Hocus Crocus is kind of a pun about Focus. That's just where I'm at right now is I'm almost to the point of throwing in the towel. But back in December, I said I'm going to do an M33 photography. I threw this into AI, said, how do I do it? It recommended exposures and said, I talked about my sky border level and where my lat long was and everything. And I did it. And this is what I was expecting to get. That's not my photo. That's just some stock photo. And this is what I actually got with my 533 MC Pro. And it was going through a rather wide field lens. And I was really psyched that it was actually showing some galaxy structure and the stars were round. So it's like, hey, this is actually working out. But when we went to process it out at the ASIG meetup, everybody universally decided all of this was out of focus. So I was like, oh, great. So this was the gear that I used out at the meetup. I have a Rokinon 135 at f2, a Skywatcher GTI mount because this only weighs about 7 pounds total. An ASI 294 that I bought from Craig, a 120 guider, a filter drawer that down here, I don't think that's a Starzona one. That's probably a different model. Filter, an ASI Air that my wife gave me for Christmas. And we measured 45 millimeters of backspace from the lens to the sensor from there to there. So all that sounds great so far. But when we started talking about why our stuff was out of focus, I had grabbed a screenshot of what was happening with my focus curve. And as you notice, there's not much of a curve there. It's pretty much a flat straight line. So everybody figured out from this clue, my star sizes weren't horrible, but they were manually focused. So what we figured out was that this little set screw right here on the autofocus, which drives a gear right here, forever will I be known as a set screw guy, was not tight on the flat spot of the shaft. So it was just spinning and not able to get focus. Well, since then, I've run there's the thing there. But I've also figured out that this is where the ring that it drives connects together. And this was coming around and hitting the gear before it got to infinity focus. So I've since moved it so that it points right at the point of infinity focus and it doesn't hit the gear anymore. So I figured that was a victory. So that's where it is right there. But you can see kind of that's infinity right there. And now that's aligned with infinity and it spins around and it stops right there. That's the end of focus. So f2 focus on a 135 millimeter with a ZWO camera is a problem. And I've been finding all kinds of stuff on Astrobin and other forums. It says I have trouble with the autofocus routine. It appears that it tries to go too far over and it gets caught on the end of infinity. And here's even the ZWO forum where somebody posted it there. And I think this might be my problem right here because when we were out there, I don't who told me to set this button to reverse, but I set the button to reverse and I haven't had a clear night to test if turning that off solves my problem. But this is what a focus curve is supposed to look like from an ASI Air, and it'll give you a focus way down here. But I never got out of to the focus point. It just beeped twice at me, indicating an error condition. But manually, I could get a star size of 1.6 to 2.4. And I did some manual focus with a Batinoff mask, which I keep on the front there all the time. And it seemed to work out. So on Sunday night, I was able to wait out the storm. And these were my settings for the focuser. Manual, I had a 10-step fine, 100-step coarse. I set the lens all the way over to the unfocused side and set it to 0. For autofocus, I was getting 1 second exposures. I matched the step size to 10, so there were tiny little step size. But I turned off this because it was trying to run the autofocus every time I changed to or in every half hour and every 2 degrees centigrade. So it was running too much and it was getting out of focus. So there was that reverse button right there. It's currently turned on. I think I really need to turn it off. So guiding was kind of okay. I was pretty impressed that my little 120 mm actually got me down to 0.61. It was doing okay. Polar alignment had a fiesta on there. I was down under 4 degrees or 4 minutes there. So I was pretty good. I made the little guy smile. If any of you guys have an ASA area, you know this is one of the first steps you have to do. But here was my rig set up at the CAC. And about 11:30, it was blowing really hard out there. I was in a trailer at the RV space and I was shaking and shaking. I'm like, this is a loss. And then I stayed up until midnight and suddenly everything was calm and the clouds were gone. So out I went, and here was the prediction from Astrospherics. There's going to be a window here. This is going to be great. So I was able to go out and the winds died down and I took flats, darks, and bias at first, and I set up 260-second lights, expecting, that's what I was going to see. M33 was gone, so I switched to M101, and I watched it run. I laid on the couch in the RV and set the tablet on the table, and I got to about 56, and then I fell asleep. Clouds were off and on, wispy and high, and then about 5 o'clock in the morning, I woke up and the tablet screen was white. I said, "Oh crap!" I burned it out, but it was dawn. So I got about 105 light images before it became dawn. And then I threw them into PixInsight, and of those 105, I believe I got 43 that it liked, and this was what I got. It's not processed past the stack phase yet, but you can see there's some galaxy there. And I'm thinking, wow, I'm starting to get some focus. What's the next thing you test? Aberration inspector, right? Look at all these comets around the edge. Holy cow. I've really got some focus issues still. I haven't gone any further than just doing the WBPP step, and that's where I'm at. So I think I need some more focus help. So I could really use some expert advice on what I should do next. And that's it.
Jim, those aren't comments. I think what you're looking at, astrophotography is a really powerful bright light on every flaw in an optical system. And at F2, at the perimeter, it's really hard to have a perfectly flat field. I think that looks to me like a really good result as far as field flatness is concerned. That's not focus. If the stars are elliptical at the perimeter and they're round in the middle, it means your field's not flat.
So that's a crop, right?
Well, with that target, you could clearly crop out the perimeter.
Okay.
Or blur exterminator.
I've got an echo. Let me turn it.
If that might be a little bit of a focal back focus. Somebody's logged in twice. We're still getting a lot of echo.
Paul, please mute your speaker. This has happened before. Your microphone.
Okay. Yeah, I think the back focus is super critical. 43 millimeters back focus versus 45 could make a difference on there. The other thing I think would be a big help is bump that up to F4. And I think it'll take a lot of it won't be near as critical on all those things.
So just as a follow-up, while we were out there, Craig Harding has the same setup as me. He uses a 2600 camera on on a 135 millimeter Rokinon. I think he's got a Samyang, but they're the same lens basically. And he says I use step down rings. So I've ordered a 77 millimeter down to 67 and a 77 millimeter down to 52 step down ring, which will lower the F ratio. So I'll probably be at F4, 4.8, 2.8, somewhere there. So I'll play with that, see if I get better results.
Well, you can just change the f-stop on the lens.
I could do that too.
That's way too easy.
Okay, this will be a continuing saga. I'll let you guys know if I make progress.
Okay, any other comments or questions for Jim?
Well, I have one. I came here off an email that said this thing started at 7, and I came in at 6:55, and it's like it's been going for a while. What happened there?
What
No,
do
we
your
started
clocks
at
say now?
I was the first one up after Jeff showed pictures of get together. I think we started at 7.
Yes.
Okay, well, it's 7:11 now. I don't know. So it hasn't been
I
going on that long, is what you're
think
telling
you
me.
better check your clock.
Yeah, I'm at 7:16 right now,
Yeah.
so you're off by about 5 minutes.
Okay.
Me too.
Okay, any other questions? Hearing none, I'm going to turn this over to Randy Smith to talk about Newtonian reflectors. And for those of you who are joined us at CAC, this will kind of be a repeat, but Randy, like a good teacher, has added a few things to his original presentation, so there'll be something for everybody. So if you're ready, Randy, feel free to share your screen and take it away.
Let's see. How are we doing there?
We can see it.
Okay. Start slideshow from the beginning. Okay. And as Greg said, the early part of this is pretty much a repeat of what the people at CAC saw, but I put in quite a bit of stuff on collimation, so that's going to be the new part that'll be towards the end. So this is about my evolution to a Newtonian telescope, and it's my quest for a greater image size, higher resolution, lighter weight, and to be able to use a filter wheel, which was one of the major parts of it. Like many of us, it started with the C8 Starzone Hyperstar AVX mount, 294 camera that was at 390 millimeter focal length, basically f2, and you had 4.63 pixels in that camera. And, you know, it worked well for a lot of things, but once you got to galaxy season, it was total frustration, lack of image size. So the solution there is to shoot off the back with the reducer and off-axis guiding. And of course, when you do that, you have to go to 100 or the 174 guide camera, the most expensive one. I also, the AVX, I could never get it to perform no matter how many times Dean worked on it and tried to tune it up at Starzone. Anyway, I went to an EQ6, and that took care of any issues with stability and reliability. Of course, you got a huge image size. You were at went from 390 millimeter focal length to about 1400 shooting off the back, but it's slow at f7. And it took 2 or 3 nights to capture enough data to get a decent image. All this is before the ASCAR OAG was available, and I think that is pretty well resolved for these guiding issues of being able to find and hold a guide star. My next move, I was inspired by Doug Summers to to move up I was inspired by his results with his RASA 11 and a 183 camera. So I didn't do the RASA because it was too heavy for my EQ6 mount, but I did go to a C11 with the Hyperstar. The RASA would be 620 millimeters, and the C11 Hyperstar was 540. So I didn't quite get as much in millimeters. Anyway, focal length is what I was after, but he was good and fast. And I got good results. I was pleased with it. And I was able, I had also added at this point, I added went to a 2600 color and also picked up a 2600 mono. And that gave me a better pixel size match. And with the filter slider, I could go ahead and start to shoot some mono imaging. But of course, you have to manually change the filters. I did find a way so you could label them in the FITS header, and then you could throw all the different images, light frames into weighted batch pre-processing, and it would actually process just as if you had a filter wheel. But I still wasn't getting the resolution I'd like. I still didn't, you go into the smaller galaxies. So I was recommended to try a Newtonian. So I went to the Skywatcher Quattro 200. That's an 8-inch. Even though it's smaller than the C11, it actually delivered better resolution. And it's a native focal length of 800 millimeters at f4 with a 1.0 corrector, but 600 millimeters f3 with a Starzona's Nexus reducer, which is an excellent product. I did give up some speed between f2 and f3, but I really couldn't see that much difference. I will point out imaging Newtonians do require correctors to achieve a flat field, and they come as a separate accessory, at least if you do Skywatcher Newtonians. Starzona has their Nexus reducer, as I said, that makes it an f3 at 600 millimeters. And I'm using a prototype Starzona 1.0 corrector, but you can also get a Skywatcher 1.0 corrector, and they're very similar in performance. They do add some extra cost. Their current prices are about $450 each. They've gone up since I bought mine. Some of the Newtonians come with integrated correctors, but as I said, not the Skywatcher. And I'll also point out visual use Newtonians are usually slower, and they don't require a corrector because you're mainly just looking at the center of the frame there. But imaging Newtonians don't necessarily work for imaging use. Imaging Newtonians don't necessarily work for visual use. You probably can't reach focus if you're using an eyepiece. So if you were to go with the Newtonian route, make sure you're getting the right version for what you intend to do. The 8-inch or 200p was cheap, about $800, but it needed some upgrades to make it work right. If you got a high-end Newtonian like Greg's ASA that he has out in New Mexico, you don't need all this. But I ended up replacing the spider, which is what holds the secondary mirror. The stock one is very spindly and it doesn't hold collimation well. The primary mirror has some flaws around the edge, so you fix that by putting a thin mirror mask that covers all the outside edge. I was getting excessive star spikes or diffraction spikes. And I found out if I put velour, very thin velour, on the spider vanes, it would take care of that. So the upgrades, of course, the velour doesn't cost anything. The upgrades were about $275. So you're a little over $800, and then you have another $900 you're going to spend on the correctors. Anyway, I also changed to a Starlight focuser, which is a $700 item. You don't need that. Really, the stock focuser, Starzona makes a minor upgrade that makes it serviceable. It's still not as good as the Starlight, but it works fine. So, as I said, higher quality Newtonians can be more difficult to find. I don't think the ASA that Greg has, I don't even think they're available now. Takahashi makes some Newtonians, but then you're down the Takahashi path where none of the normally used accessories work with them. There's an Italian brand, I think it's called Artec, that makes some very high quality Newtonians. You're probably talking $7,000 range for one of theirs. I ended up upgrading the mount, not for this, didn't need it at all, but I have a wind problem. And I was interested in a mount that was just heavier and sturdier against wind. And also I wanted to get a mount that would handle any scope that I would ever have in the future. And the 350 goes up to 77 pounds capacity. And I ended up adding a 10-inch Newtonian, and that works great on that mount. Just as an aside here, it doesn't have anything to do with Newtonians, but I found a good way to knock the wind down was a Harbor Freight mesh tarp. And here's what it looks like. I just put a 2x4x8 board attached to the block wall, and then put just some eye bolts in the side of my house that go into a stud. And so here's my wind barrier. It doesn't totally block the wind, but it sure slows it down enough that it's not an issue. What happens at night is a north wind will start to move, and it gets focused by the side of my house, and like a Venturi effect. And you can, if I step over behind the house, you'd feel no air, but it might be blowing 4 or 5 miles an hour if you step where the telescope is, which is the only place I can see Polaris in our yard. So this really has helped things. Okay, let's talk about the Newtonian itself. It's a very simple scope. It's open to the weather on the end the light comes in on, so you do have an issue with your mirrors eventually they're going to definitely get dusty and can eventually get dirty, but doesn't seem to make a whole lot of difference till they're really bad. Anyway, the light comes in, goes to the back. It's a concave mirror that's either parabolic or hyperbolic. Then it's reflected back to a flat mirror that's set at 45 degrees, and that projects the image up through either the eyepiece or that's where the focuser is, and you put your camera there. The flat mirror is actually oval in shape. Anyway, it's a very simple scope. Isaac Newton came up with this design, and this was his kind of first telescope he built in 1671. This is a replica. It was 50 millimeter, 2-inch, and 158 millimeters in an f3. From what I can read, he was frustrated by the refractors of the day having a lot of chromatic aberration, where it was basically acting like a prism, spreading the light into its component parts. And his theory was if he used mirrors rather than lenses, he could defeat that, and evidently that worked here. He made this mirror out of, I think, some kind of metal alloy that then he hand ground. And from the comments, it was not bright aluminum like we would have today as a mirror coating. But it was dark, but it did prove its concept. And of course, the basic design is still around today. Here's my 8-inch Skywatcher. I no longer use that big, heavy guide scope on top. I found out that you don't need it at all. With this, just a plain old 30 millimeter introductory level guide scope with a 120 camera is perfectly adequate to guide with this. I think part of the reason is that it may be where it mounts on this is better. Anyway, of course, the ASI Air is on top, and the dongle there is just a Wi-Fi extender. But you can see how the whole imaging train, which weighs about 4 pounds, is all hanging on the focuser. And it's a little scary, but I've never had any issue with it getting away and crashing to the ground. So, and here's the filter wheel and camera, so you can just see how that all works. With a 2600 and shooting with the Nexus reducer at 600 millimeters, here is your image frame. So you can squeeze in most of the rosette. You can squeeze in Andromeda as well if you get the angle right. But you do get some pretty nice detail, and you get some nice sharp stars. And unless you're offended by the diffraction spikes, which I kind of like them now that I'm used to them, you can get a little better idea of what the detail it produces. Again, this is the same scope, and the shark really does fill up your image frame with the 2600. I've also added, as I said, the 10-inch Newtonian, which is f4 at 1,000 millimeters native and 750 with the Nexus reducer. And I'm shooting 2 rigs now, and for the other rig, lighter rig, I picked up a Sharpstar 5-inch Newtonian, very fast at f2.8. This one comes with a included or integrated corrector. So you're at 360 millimeters. I do have for wider field, I've got a Samyang 135, the ASCAR FMA 180 at 180 millimeters, and then I just picked up an ASCAR FRA 300. Yeah, it's probably going to be a little overlap with the 5-inch Newtonian. So, but that's what I've got there. Here's the 10-inch, and it's pushed way forward on the mount. And you can see I have 10 pounds of counterweight back on the, so that you can balance in deck. If I slide this any farther back on the saddle, it will hit the tripod legs. If I were on a pier, it would be a lot better there. But so I'm really loading things up here just to get good balance in deck. But again, with this mount, it handles it all just fine. And you can see just even with at 1,000 millimeter focal length, this little 30 millimeter guide scope is totally adequate. Just to show you, when I went from the C11 Hyperstar with the 183 camera at 540, here's what I would get with the Croc's Eye, which felt pretty good at the time. The stars are a little bloaty, but it's not a bad image. But when you go from 540 to 1,000 millimeters, even at f4, here's what you can get: much tighter stars and so much more detail. And I've been using this just with the ASI 585 camera, and this is cropped a little bit on the sides, but with this sensor is so small that any of these small galaxies really do fill the frame. Here's another example of what I've got with that same rig. The other nice thing is the file size are so small that you can stack them in 30 minutes, even if you have 10 hours of data. And the last one, again, with that same rig. So again, this is only cropped left, right, not top to bottom. Here it is with the 2600 camera. So you can just get the Leo triplet in the field of view. So this is the little sharp star I picked up. It is really short and stubby, so much that there's no way you're going to hang the imaging train down on the bottom without it and have it not hit the mount. So it makes for terrible momentum arm, but it doesn't seem to be an issue. It works just fine. And I haven't had any guiding issues with it. I will say this scope has hyperbolic mirror versus the parabolic. It is super sensitive to collimation. So it's, I would caution anyone before they got one of these to make sure they were comfortable with collimating. And although I know at least one other of our imagers, this is the older version with a carbon fiber. The version that's out now seems to be a little bit easier. This one I bought used, and I had a terrible time getting the focuser, or excuse me, getting the secondary mirror in the right position. I think I finally got it there now. Here's an example of the image size that you get with that rig at 360 millimeters. Okay, here's my observation conclusion. The C8 Hyperstar was great, except it lacked detail on a lot of the smaller nebulas. Shooting off the back was just pure frustration, and I see a pain in the rear. Moving up to the C11 Hyperstar, that worked well, but that thing was so heavy that I struggled to get it on and off the mount. I did find if using a table, I could do it better. But still, you weren't going to get to a filter wheel doing that. So the Newtonian mostly solved my issues. I had nice image size at 600, and with the corrector could get up to 800 millimeters, which was good for galaxies. Not as good as 1,000, but still pretty darn good. Overall cost upgraded, even with the accessories you need. It still came in cheaper than a RASA or C11 Hyperstar. And I felt like the images it produces were superior. Of course, the diffraction spikes, they come because it's the spider, or it's the spider veins that produce them. Any scope that has that kind of arrangement at the front, you're going to get diffraction spikes. So I'd say if the Newtonians are the sliced bread of telescopes, why isn't everybody using one? Well, here's a few reasons. They're very awkward for visual observing. Even if you do have one, you could achieve focus. With having, well, you've all done the Dobsonians where you may have to climb a ladder to get to it, and there's only one place that you can actually look through it. Higher focal length newts are somewhat long and unwieldy, and they can be a sail in the wind. So if you have a wind issue, you have to take that into consideration. Refractors come from the factory collimated and generally never require any adjustment there unless something happens to them. SCT collimation is generally stable and not all that hard to do, but of course, and they're great. SCTs are great for visual observing. And of course, the limited availability of quality newts. But the biggest reason it may be collimation. So we're going to talk about collimation. It's the process of aligning the focuser, the secondary, and the primary mirrors. makes collimation a circular process. You change one thing, and the other two change. You change one of those two, and then the first thing changes. So it becomes an iteration process. So here's what you actually do. And first, you got to make sure your secondary mirror is in the right place. It can move away and towards the primary mirror. There's a kind of a central screw that actually moves it that way. It can be rotated, and also it can be tilted. So all of those things have to be in the done right for the secondary mirror to be in the correct position. For me, that was very difficult. Fortunately, Starizona set that before I took it home. And once the secondary mirror is set, then it tends to stay there. And I haven't had to adjust it in like 2 years of use. So if you look through a sight tube, this would show you what a well-positioned secondary mirror looks like. The kind of dark ring around the outside is the edge of the focuser. Then the lighter wide part is your primary mirror, and the center bright part, that's your secondary mirror. Even though that mirror is oval, when it's in the right position, it appears perfectly round. So as you can see, everything here is concentric. So that's how I know everything is the way it should be. And what we're looking at here, this is a sight tube. You put it in the focuser, and that's what you're looking for. You can just see how everything is lined up. The next thing you want to do is adjust the secondary mirror tilt. And for this, we're going to use a laser beam. And there is a donut or a center spot in the primary mirror. And it doesn't look quite like this when you're actually doing it, but if you see that little red part, this is a triangle. Some center spots looks like a gummed reinforcement, and you call them a donut. This version has a red triangle with an open center. So what you see is a laser that's inserted into the focuser, and the secondary mirror has been adjusted so the laser beam hits exactly the center of the primary mirror center spot. Here's some examples of lasers. The one on the left is a Howie Gladder. It's kind of the highest end laser you can get. It produces a really tight laser beam, and it fits very snugly in a 2-inch focuser. So you have very little play in there. The red one is, again, it's a good quality. This is called Farpoint, and it doesn't cost as much, but it's still a very good quality. This one happens to be usable for a 2-inch focuser or the narrower part for a 1 1/4-inch focuser. The other two things are what are called Cheshire eyepieces. On the inside that you don't see, they have a reflective ring, and then these are just center holes that you look through. You use those to adjust your primary mirror. And that is our third thing that we do. We adjust the primary mirror to center you're going to, at this point, you're going to get you want to get the center spot in the center of the Cheshire eyepiece. It looks different than, you can use the Cheshire eyepiece, or there's something called a tube lug. This is a very cheap, like $25 or $35. This is a combination laser, and also it's a 1 1/4-inch with a 2-inch adapter, and I'll show you what we do with that. But it's a target here that helps you align your primary mirror. This is a Hotech version of the same thing. It costs, I think, $140 or $50 for one of these. And this is one that Starlight Instruments makes. and it's meant to have a Howie ladder laser put in the left end, and the right end goes into the focuser. And here's how it works. With the laser is shooting into the focuser. It's reflecting off the secondary mirror. It's going to the primary mirror, and then it's being reflected back. And what you want to do is adjust the primary mirror until the laser spot disappears into the hole. So here it is. You can see just a little bit of glow, but now the primary mirror is adjusted by just adjusting the adjusters on the primary mirror until laser spot goes home. Then you go back and repeat steps 2 and 3, because by now you've probably, with your primary mirror adjustment, you have more than likely now your center spot on the secondary mirror may be off. So you repeat getting that laser beam in the center of that, and then you go back to the primary mirror and make that adjustment. So it might take you 2 or 3 times back and forth, and then all of a sudden everything is in perfect alignment. And then it looks like this. You can put your sight tube back in there. Now everything's in alignment. So that's all there is to collimation. It's not as scary as you think after you've done it a while and things stay more stable. I know I'm able to roll my scope. It's on a trolley, but I'm able to roll it quite a ways over a not terribly smooth concrete, and where I shelter it under a patio cover and then roll it back. I will look quickly to see where we are collimation wise, but a lot of times I don't need to make any adjustments, or maybe just a very minor adjustment there. So it's just not that big a deal. And if I leave it there for several nights in a row, just, with a cover on it, collimation doesn't change at all. There are other collimation devices out there. This is Ocal electronic collimator. It's actually a little camera. You put that into the focuser, and you hook this up to a PC, and there's some rings, just optical rings that you can size, and you put one ring on the primary mirror or one ring on the focuser outline and another one on the secondary mirror, and you can make adjustments to it and see on your iPad screen what's going on. And it works well, and it's very precise. There are some other collimation tools. There's a system called Cat's Eye Collimation, and I'm sure there's others out there as well. So since collimation has been around since 1671, a lot of people have come up with different systems on how to do it. So why didn't I go the refractor route or stay with a larger SCT? Well, when I saw the Newtonian images, I like the star spikes. I like the sharpness of the results. I like the image size available, and the fact that with 2 different correctors, you could get 2 different image or focal lengths out of the same scope. Also considered the economics. You could get an awful lot of aperture and speed for the money compared with a large refractor. Of course, SCTs work, but you'll never put a filter wheel on. And the collimation tools and correctors, they're a one-time expense. And the Nexus and 1.0 corrector fits all of the different, there's 5 different Skywatcher Newtonians, and those 2 items work with every one of them. So you can go clear up to a 12-inch. I would get a 12-inch, but I would never be able to get it up on the mount without having a buddy come over and help. Anyway, shooting at 750 millimeters at f3 or 1000 at f4 with a 10-inch aperture is a real advantage for small targets. and 600 millimeters with the 8-inch scope is really a good all-around focal length for a lot of nebulas. So maybe I just like torturing myself. So that's all I've got. Questions? Anybody out there?
Can you hear me?
Yeah.
Yeah, hi. I'm relatively new to all this, so I'm just wondering, why is it not possible to use a filter wheel with an SET?
Because it would block almost all the incoming light. You you could use it on the back, but you could but if you want to use it with a hyperstar on the front, or then that's where the problem comes. But
Oh, okay.
yes, yeah, you could put it on the back.
I understand. Good to know, because I have
Yeah,
I have an SET and I've considered that, so I didn't know that.
yeah,
Thank you.
sure. Anything else?
Randy, you didn't mention anything about light leaking in the front, so I noticed none of your scopes had a dew shield on them. But I know some Newtonians, especially the fast ones, light can actually kind of leak into the focuser if it's too close to the front of the tube. Have you had that issue?
No, I haven't. Um, but I mean, you can easily put a dew shield on it. I've just never had the need here, and I can't tell you why.
Yeah,
But
I think it has to do with how much tube there is in front of the focuser. So if there's enough tube there, then the light can't leak in. But if this tube is real short and the focuser is close to the front end, you can get light leaking in.
well, I could, and that's a lot more likely with that Sharp Star because um, it's right up at the front. But uh, and I don't know what it's like with your ASA. Of course, uh, in New Mexico, you may not have any issue at all with that. So, but it's likely that you would need a dew shield.
Yeah, I do use a dew shield just to kind of be on the safe side.
Uh-huh.
I have a
Any,
question,
uh-huh.
and I'm completely new to this whole Newtonian thing. I just have an SC. I have like your original rig,
Uh-huh.
and it's SCT 8-inch with a Hyperstar. What is this focuser thing you're talking about? It's not a thing on my scope. It's just a focus knob, but
Oh, okay.
certainly not that.
Well, on your SCT, that focus knob is attached to the primary mirror, and it's
Uh-huh.
actually moving your mirror, uh, in farther or back farther.
Okay.
So a focuser it's doing the same thing, but it's moving the entire imaging train, and it's all on the outside. So, and the
Okay.
focuser may have 1.5 or 2 inches of travel.
Okay.
Anything else? So anyway,
Questions?
uh-huh. Yeah.
Okay, I think you've given us a lot to think about, particularly about the collimation. So that was a good addition.
Well, it's um, it's something you worry the most about, but after you've done it, um, at least with the Skywatcher Newtonian, it's just not a big deal. And to me, it's just a minor thing that I wouldn't worry about. Now, with that Sharp Star, I don't know. The jury is still out there. Um, that hyperbolic mirror is just so much more sensitive, and you get some extra speed with it. But I question whether it's worth that.
And my name's Werner. Two things. I sold my Sharp Star because every time I stored the thing and I stored it horizontally, I had to recollimate after storing it for like a week after I pulled it off the mount. It
Yeah.
was just that sensitive. And I actually upgraded the mounting of the mirror. They sell some kind of Teflon mounts instead of the rubberized mounts. And even then, it still sagged a little bit. And then the second question with regards to the focuser is on my unit, which I think was a Sharp Star. I sold it a year and a half ago or so. I was able to put a ZWO autofocuser on it, and that worked actually quite well. So I don't remember how I did it, but so there's that knob that you can do the manual focus on, and I was able to pull that off and put a ZWO autofocuser on it.
Well, I have that on all my scopes.
Yeah, okay.
Yeah, no, that it's really it's a straightforward add-on to the focusers on the Newtonians.
Yeah, and I was never able to actually get it to work on my Celestron SCT. It's just too finicky the way I don't know if they fixed that now, but the older SCTs, they used to just like tilt the mirror to focus it. It's kind of,
I don't know. My C11, it worked fine with
okay.
the EAF focuser.
All right, thanks.
Sure.
Other questions?
I got one.
Go ahead.
How does that EQ 350 mount perform? What kind of guiding accuracy does it give you?
You're going to get between 0.4 and 0.6. I don't pay all that much attention to the numbers. If the stars look good, fine. And if anything under 1, it seems to produce good results. So, and then there's always Blur Exterminator that seems to fix a multitude of issues. So I've even had good results when it said it was, you've got some wind or something going on and it'd be over 1 and still you got usable stuff out of it. It's a very heavy mount. The tripod weighs 40 pounds. The mount weighs 40 pounds. It's extremely, and you've got 2 22-pound counterweights. But it is super easy to balance because the gears totally disengage. And so it will balance perfectly because of that.
My Celestron CGXL, which is a comparable mount, weighs even more. It's even heavier. The equatorial head itself is around 46 pounds, and the tripod is about that too.
Well, all I know is if it were not on a tripod, I would never own it. Or excuse me, a trolley. On a trolley. Anything else?
Okay. Well, thank you, Randy. That was great.
You're welcome.
Any other comments or questions?
Yeah, this is for Randy.
Okay.
Yeah, Dan Sharako here. This is my first time on this platform. The presentation was very informative and really appreciate the content. Also, I didn't know that choosing an imaging scope would be a poor choice for visual use. And actually, you saved me a very costly mistake. So
Good.
I appreciate that information. That's all I have.
Okay.
Good.
Glad to help.
Okay. I just want to remind everybody, our next meeting will be the May meeting. That'll be on the 3rd Monday as usual. That's May the 18th. Again, if you have topics that you'd like to hear discussed or topics that you yourself would like to present, please feel free to contact me or Jeff Rothstein, either one of us, and let us know what you'd like to hear about. And that's how we try to make sure that the content of these meetings is appropriate and applicable to the largest number of folks. All right. Thank you very much. And if that's it, I'll end the meeting for this evening.
Good night, all.
Bye.